Welcome, and in this lesson, we're going to learn how to set up key-based authentication to remote servers. Now, up until this point, we've been using passwords, usernames, local user accounts, and passwords to connect to our linuxacademy.com lab servers. However, inside of a production environment or even on your local machine, for an additional layer of security, we should always try to use key-based authentication. Now, key-based authentication allows us to generate a private key, which is encrypted with the DSA or RSA encryption algorithms, and then it also associates or creates an associated public key. What happens is our public key will be stored on the remote machines that we're attempting to connect to. Our private key will be stored on the machine we're connecting from. Now, our public key can be out in the wild. Technically, we could actually give it to anybody, and it won't be considered a security issue. Our private key, however, is our authentication method. We need to make sure that is protected and that we don't give that out. The public key, it's okay, but the private key, it is not. The public key is used to verify the private key. So if the public key exists on the remote system and it matches our private key we're using to connect to the remote system with, then authentication is allowed. So let's go ahead and get started. I've logged in to my first linuxacademy.com lab server. That is my server 1 right here. I am then going to try to set up key-based authentication to my server 2. So in order to do this, I'm going to maintain doing this as the user. If we wanted to do it as a user root, we could. Ideally, in a production environment, we would just set this up to a privileged user. So first, what I have to do is I have to generate my signed SSH keys. To do that, I'll do SSH-keygen. Now, there's two different types of encryption algorithms I could choose to use. To specify the type, you would do -t. It could either be DSA or RSA. Now, RSA is technically speaking a little bit faster when it comes to verifying public key and private key. It can also be used to encrypt different items like a file or directory. However, DSA and RSA encryption basically have the same encryption strength. In terms of which one that you need to worry about using in the exam, it doesn't matter. So the default on a Red Hat machine is actually RSA. So if we don't specify the -t, it'll automatically be RSA. So we're just going to use the RSA. Now, what it's doing here is it's asking, where do you want to save your private and public key? Because it's going to generate a public key, which we can then distribute out to our remote machines. By default, it's inside of r/home/user.ssh directory. Keep in mind, we're working as the user. That's why it's going in the user's home directory underneath the hidden directory .ssh. We're going to leave that to default. Now it's going to ask us to enter in a passphrase. Passphrase is suggested. Now, even though we have key authentication and our public keys can be given to anyone because that just verifies our private key, we need to make sure our private key is protected. If somebody gets access to your private key, then they can compromise or have access to any system that has a public key associated with it. How can we better protect it? Well, we would add a passphrase. So I'm going to go ahead and enter in that passphrase. It's going to ask me to verify it. And now our private key is protected with our passphrase. So now what I can do is I can copy my public key. So where's my public key at? Well, it's inside of my .ssh directory. So in order to see that, we'll need to do a -a. We'll see our .ssh. Let's navigate into the .ssh directory. And you'll see that we have our ID RSA, which is our private key. We keep that for ourselves. Our public key is what we distribute out to verify our private key. So what does our public key look like? Our public key is an encryption string that just verifies our private key. So now that we have that, let's copy it up there. I could copy the file. I could copy the contents in my file. Instead, why don't I make it easy? So I'm just going to copy it because I'm going to create passwordless authentication to this host, my second linuxacademy.com lab server. So I can do ssh-copy-id. So I do need to enter in user credentials. I'm going to copy this to the user on my secondary linuxacademy.com lab server. So I'll do ssh-copy-id user at, and then my IP address. I'm going to go through regular authentication to copy it up there. And you'll notice we've copied it up there now. So if I wanted to, I could say SSH user, and I'm just going to SSH into that system. Now, it is going to ask for my passphrase. It's no longer asking for my local user account password, but it is asking for my passphrase. So we'll enter in my passphrase. And we have successfully logged in. So one of the cool things that we can do now that we have authentication set up is we could say SSH user, and then of course we're just using credentials to connect to it, and then we can issue a command. So I'll type in my password for my passphrase, and it issued the ls command on the remote server. So we can even write scripts that connect to remote servers to get information or execute commands without having to enter in credentials. And this is a lot of how bash automation works with different servers. But you might say, well, I still have to enter in my passphrase. Well, for our current shell session, we can still keep our elevated security permissions with the passphrase, but have it so we don't have to continuously enter it for this specific session. So how would I do that? I would just type SSH agent bash, then I would say SSH add. So what that's going to do is it's going to add inside of basically a cache for our current logged in session our passphrase. So I'll enter in my passphrase for the key. Now this is only for my current logged in session. So now when I connect to the remote server, if I do SSH user at my secondary lab server and I issue a command, I can just issue that command without any credentials. Why? Because the public key is verifying my private key. The public key, which is inside of my remote system, is verifying my private key, which is on my system I'm connecting from. And if they match, we can connect. So for example, let's connect to our remote machine using our neat little feature. Let's issue a couple commands, cd.ssh, then let's do an ls inside of our SSH directory. We're inside of there and we see that we have our pub key. And so that's how we create passwordless authentication. Now, if I wanted to remove that, we could do SSH user, and then I could actually remove the .ssh directory. So if we remove the .ssh directory and we attempted to connect to our remote machine, it's going to ask for our local user's password. We no longer have that authentication. And we can put it back up there by doing SSH copy ID, and then we're going to copy it up to our secondary linuxacademy.com lab server. We'll enter our local user password once, and now we can connect to it. But inside of our session, it still had our passphrase stored. So if I exit out of my linuxacademy.com lab server and I SSH back into it and I attempt to connect to my remote server, my secondary server again, it's going to ask for my passphrase because again, we can store that temporarily for our current shell session by doing an SSH agent bash, then an SSH add. And then we type in our passphrase and it stores it temporarily until we log out and log back in and we can connect to our system remotely. So that concludes it for this lesson. In this lesson, we learned how to set up passwordless authentication from one machine to another machine. We learned that our private key needs to live on our local machine and our public key can be distributed out. Now, real quick, permissions on a private key need to be 600. Permissions on a public key need to be 644. The private key should only be able to be read and executed by the owner of the file. The public key, we can allow anybody to read it because it's okay, because that just verifies our private key. So that concludes it for this lesson. Go ahead and complete this lesson.